Welcome everybody. This is Algebra 2. I am Mrs. Bannock. I teach at Oak Forest High School.
And I'm Miss Dasher, and I teach at Tinley Park High School.
We are so excited to give you a whole new experience to learning. Through video lessons, you'll learn concepts and understand all the things that we teach typically in the daytime, only you'll be doing it in the perhaps comforts of your own home with your bunny slippers on. Or perhaps
You could be coming home from a volleyball game on the bus using your smartphone.
or if you didn't have time to look at it at home and you have a study hour before class, you can go ahead to the IMC and feel free to either bring your own headphones or they'll have some in the IMC and you can watch the video lesson there. After you're done watching the video lesson, the next day we will be doing an assignment that corresponds to the lesson. So it's called a flipped classroom experience for the exact reason of what it sounds like. We're going to flip when you do your homework and when you do your lessons. So before we get started though, we want to make sure that you're prepared before you sit down with those bunny slippers and you have perhaps something to drink, and you can also make sure you have, Miss Dasher, I forgot, what else do they need?
Paper and pencil. We're going to be checking these notes tomorrow when you come in one way or another. You will be graded on this. So it's important though, even though you're comfortable and you're at home or you're on the bus or wherever you may be, that you also understand that we are taking serious notes here and you will be expected to take quality notes to bring to class tomorrow.
All right, very good. So let's get started.
In today's lesson, we're going to be starting with the basics of algebra. At the end of this lesson, you should be able to arrange numbers from least to greatest, successfully follow the order of operations without a calculator, evaluate algebraic expressions, and solve some pretty basic equations.
Okay, now you said without a calculator, but should they have a calculator with them? Are we going to use one at all?
Absolutely, you should always have a calculator available to you whenever we're taking these notes.
So what if they don't have one right now? What should they be doing right now?
Pause, step away from the computer or smartphone, find your calculator, and come back and press play.
Okay, we're going to go real basic right here in example 1. We are going to want to arrange these in order from the least to the greatest. So what we need our calculator for is to know what the value of the square root of 2 is. So go ahead on your calculator and press the square root of 2. I already know that it's approximately 1.4. Hopefully you discovered that too. So we have 1.4, 2.7, and now 4/3 is actually, fractions are division. So if you're wondering how to do that, just put 4 divided by 3, and you're going to get 1.3 repeating. All right, so that's what we're working with, and we want to arrange them from the least to the greatest. So we're deciding between the 1.4 and the 1.3, and which is smaller, the 3 or the 4. We're going to look at that tenths place value, and it looks like the 3. So 4/3 is the least, and we're going to graph that on a number line. You can see on the right that we've already graphed that point. You'll have things popping up on the screen from time to time, so be aware that we're trying to move things along quickly and things will suddenly just appear, so be looking for that. So we have the 4/3. And now we know that the square root of 2, 1.4, is the next largest number. So we're going to slide that over and put it next to that 4/3. You can see the green and the yellow dot there. And finally, we have 2.7 will be the largest number, and we'll graph that as well. So that's the order from least to greatest: 4/3, square root of 2, and 2.7. You're going to want to use your calculator to see what decimal value they hold so you can arrange them in that order.
All right, let's take a look at example 2, very similar, except for now we're going into negatives. Once again, we've got a fraction, negative 19/6. If you do negative 19 divided by 6 on your calculator, you're going to get approximately negative 3.2 when you round. Negative square root of 1, you need to be careful typing that in your calculator because the negative is in front of the square root, or you should be able to do this without a calculator. Square root of 1 is 1, then it's being multiplied by a negative, so that's just going to be exactly negative 1.
Do you know, Miss Dash, that a lot of people don't know that the square root of 1 is 1? They miss that one a lot. But what
Yeah.
does the square root of 1 really mean?
Just means what times itself makes 1. So
Oh,
1 times 1 makes 1, so square root of 1 is 1. Easy as that. And then obviously negative 5.312, we already have the decimal for that. So now we need to think on the negative part of the number line, which of those is the smallest or the least. So thinking of which one's going to be the least, that's going to end up being negative 5.312.
is that because it's the furthest away from 0?
Yes, absolutely. It's the furthest away from 0, so that's going to make it the smallest. So it's the furthest to the left on the number line.
Ah,
Next, the next smallest one is going to be that negative 3.2, that yellow one. So we're going to make that yellow dot, and I'll drag over that value for us to see.
well,
And
Miss Dasher, how come you didn't put negative 3.2? Why'd you put a negative 19 over 6?
whenever we're doing one of these problems, you always need to list your answer with the exact thing that you began with. So we don't want the approximate value, we want exactly what we began with, which is negative 19.6. So if you put negative 3.2 in your answer, I'm going to mark it wrong because that wasn't part of the original problem.
You're getting awful technical.
Well, that's what we're going to do here. We need to be precise in Algebra 2.
Stepping it up, are we?
Yep, that we are. Lastly, we've got negative 1 or negative square root of 1. And so we have our order from least to greatest is negative 5.312, negative 19.6, and then negative square root of 1.
Okay, so now let's move on to simplifying expressions, and we're not going to be using a calculator today, so show each step without, whoa, Miss Dasher, what are we doing?
Well, before we begin, I think there's some prerequisite knowledge that these kids need to know before we start doing these examples.
So what's the white arrow for? Are you going to use that all the time? Are white arrows always going to be PK, PK, PK?
Absolutely. Anytime I drag something down from the top of the screen that's in a white arrow, that's information that really we're hoping that you already know, but if you don't, we're going to take the time to review it with you. So in this particular example, when we're simplifying expressions, we need to know the order of operations.
Very important, yes.
And most of us are pretty good about remembering PEMDAS, or please excuse my dear Aunt Sally. The problem that comes in that we really want to highlight here is that PEMDAS is great, but it falls short.
They're missing something in there, aren't they?
There's something very important that they're missing, and that's the confusion with following these orders exactly the way that they're written. The first thing we do
So
is,
does multiplication come before division?
does multiplication come before division? The answer is sometimes.
Okay.
You need to consider that multiplication and division are really the same operation. Multiplying and dividing accomplish the same goal.
So they have the same value of importance when we're following the order.
Absolutely. So multiplication is not always going to come first. You're going to do whichever comes first, multiplication or division, which means you're going to read it from left to right, and whichever one occurs first, that's what you're going to do.
So just like if we were reading a sentence, we start on the left and we move to the right. So same thing with a mathematical sentence. We read it from left to right. Whoever shows up first, if it's division first, we're going to do the division before the multiplication.
Absolutely.
Okay, will we do the parentheses before the exponents? Does that work?
Yes.
Okay.
That still works. Everything works. You just need to be careful with multiplication and division.
Okay, so parentheses, exponents, multiplication, division, from left to right. And I'm going to guess then that addition and subtraction are on the same level, but that's going to be from left to right. Is that pretty true?
Absolutely. So they follow those same rules.
All right, thanks for the PK. Let's move on. All right, so in example 1, we have 4 plus 6 divided by 2 minus 1. So as I'm talking, you've been writing down this example and you have it in your notes. When we do order of operation, we're going to ask that you clearly do one step at a time. So I'm going to rewrite the 4 because I'm not using it yet. But 6 divided by 2 is 3, so I'm going to show that I'm doing one step. 6 divided by 2 is 3, and then subtracting the 1. Now, order of operation said whatever comes first from left to right. So it looks like the addition comes before the subtraction. And the answer there is 7. 7 minus 1 is 6. Let's circle our answer, and we are finished with number 1.
And Miss Bannock, I noticed you showed all of those steps along the way. Do I really have to do that?
And if you really want the credit, you'll really have to show it because we're not going to be using a calculator. So I'd like to see your thinking process.
Okay. Example 2 goes along with what we were talking about in our PK, our white arrow up there, and understanding that the order of operations with PEMDAS is helpful. However, you have to remember multiplying and dividing occurs from left to right, not always multiplication
Okay,
first.
well, let's have them take a look at this and let them do the problem first before we show them how to do it. And let's see what answer they come up with.
So why don't you go ahead, hit the pause key right now, and come back to us when you tried the problem out.
Well, welcome back. Let's take a look at what you got. Did you by chance get the answer of 4? Oh, not the right answer, Miss Dasher?
No, absolutely wrong. If you got the answer of 4, you didn't listen to what we talked about with the PK. You most likely went ahead and multiplied first. You should not be multiplying first because division happens first in this problem. You have to do it from left to right. The first thing that happens is division, so that's what we're going to do. 32 divided by 4, which is 8. 8 times 2, which is 16. It's an order of operations. If you don't follow it, you're going to get the wrong answer. It might seem like you're doing it right, but in the end of the day, it's not the same thing. Correct answer is 16.
Okay, so we would like for you to do an example. Whoa, Miss Dasher, what are we doing here?
Right now we're going to do a you try problem. Anytime I pull out one of these yellow arrows here, that's a you try, meaning you need to work it out on your own.
So is this like a check-in to see if you understood the concept kind of idea?
Absolutely. So you're going to write down this problem, give it your best shot, hit the pause key, and when you come back, we're going to reveal the answer.
Good luck. All right, well, if you did a great job, you got an answer of 425. If by chance you did not, go back and try it again, or you can always ask questions in class and the next day, and we'll be happy to show you how we got that answer of 425. We're going to move on to the next slide.
All right, now I want to ask you a very important question. What is the difference between negative 3 squared and the quantity negative 3 squared?
Miss Dasher, I've been teaching this for 100 years. I cannot get them to understand the difference between these two, especially with these darn calculators that they use.
All right, well, first of all, let's talk about what they have in common. Obviously, you can see there's a squared in both of them. Now, the question of what's different here is you can see that there are parentheses in the second one. In the second one, what we're squaring is everything inside of those parentheses. So in other words, remembering what squaring means, multiplying that number by itself twice, that's exactly what we're going to do. Our number here is negative 3 being multiplied 2 times. That's very different than the other part, which doesn't have any parentheses. In this case, we're just squaring the 3. The negative's not part of it. So we're going to do our 3 squared, which is 3 times 3. How does the negative come in? Well, we're just multiplying that expression there with a negative. So I've got negative 3 times 3, which is negative 9, versus negative 3 times negative 3, which is positive 9. That's a whole lot different. I want to see that positive 9 in my bank account, not the negative. All right, let's try an example with this now. We're going to be evaluating the expression ab squared minus c when a is 3/4, b is negative 8, and c is 3. Something I know I want to see you doing in these problems is plugging things in parentheses.
So always put your subs in parentheses.
Always, okay? I don't want anyone falling into the trap of what we just talked about where you make a mistake because you didn't put something in parentheses. So let's go ahead. All I'm going to do is substitute in my a, b, and c values. So I get 3/4 in my a spot times my b, which is a negative 8 squared, minus my c, which is 3. I'm going to simplify using the order of operations. So the first thing I'm going to do is, I know a lot of you are saying, there's parentheses, Miss Dasher. All right, yes, there are parentheses, but there's nothing to evaluate inside of those parentheses. So we're going to move on to the exponent. So my exponent here, I've got a squared. and that's attached to my negative 8. This is exactly what we talked about up here in this example. The negative 8 is in parentheses, so I'm doing negative 8 times negative 8, which is a positive 64. Everything else stays the same. I'm showing each step along the way so that I gain full credit.
All right, so let's do the multiplication. We'll cross cancel, put that 4 into the 64, and we get our 16. 3 times 16, 48. 48 minus 3, final answer, 45.
All right, we're going to start going through these a little bit quicker for those people who can handle the faster pace. Now, if you're not one of those people, that's okay. Pause, rewind, slow it down. That's what the benefit of these videos are. Here we go.
All right, well, we read the problem so that you can write as we read. 13a plus 6 minus 14a equals 7. This is an equation, and so we're going to combine things on the same side of the equation. So 13a minus 14a is negative 8. A plus 6 equals 17. And now we have to get the variable alone. We'll subtract 6 from both sides. Negative a equals 11. And remember, when we do our algebra, you can never have the variable negative, so we're going to get rid of that negative a by dividing by a negative 1. And so the final answer is a equals negative 11.
All right, for the second example, I'm going to go ahead and simplify this first by distributing the negative 7. We began with negative 7 times the quantity y minus 3 equals 35. When I distribute, I get negative 7y plus 21 is equal to 35. And now we have a two-step equation, pretty simple. Subtract 21 from both sides. I end up with negative 7y equal to positive 14. Divide both sides by negative 7. And I get y is equal to negative 2.
You know, Ms. Dasher, there's another way to do that I think is a little bit faster. Can we just maybe down below in a different color handle this problem a different way?
Okay.
All right, well, let's see if the students understand that we could simply take that negative 7, since it's multiplying the quantity, we can actually undo multiplication with division and divide both sides by negative 7. And so you're left with y minus 3 equals that negative 5. Add 3 to both sides, and we get to the negative 2. Either way, we got to the same answer. Depends on how you see that problem. Okay, so now you see in example 3, we have y over 4 plus 1/12 equals y over 3 minus 1/6. The best way to handle this problem, and let's get comfortable with this, is to clear the denominator. So what we do is we look at the 4, the 12, the 3, and the 6, and we look for a number that they all have in common. And lucky for us, 12 is the number they all have in common. So the least common multiple is 12. So what we'll do is we'll take each fraction and we'll multiply it by that 12. Now let's look at this carefully from left to right. Let's see how many times that 4 goes into the 12. It goes in there 3 times, so we're left with 3y. That cleared out the 4. Now let's clear out the 12. We're left with 1. And if we clear out that 3 in the denominator, it goes into the 12 4 times. Don't forget that y. 4 times y is 4y. 6 goes into 12 twice, and there's nothing else, so minus 2. Now we just have a simple equation where we need to get the variables on one side, numbers on the other. I'm going to move that negative 3 over, join it with that 4y, and I'm left with 1 equals 1y minus 2. And add 2 to both sides, and we're left with y equals 3. You can write it as 3 equals y, or change it to y equals 3. Both are the same.
All right, we're going to do a similar example with decimals where we're going to clear it. We're beginning with 5.85n minus 9 equals 2.7. For this one, we're going to clear by moving the decimal over the maximum number of spaces we need to. In our first term, 5.85n, there are 2 spots after the decimal. There's nothing after the 9, and there's one thing after the 7. Or the 7 is one thing past the decimal point. So we're going to move everything to maximum, which is 2. So everything needs to get shifted over 2 spots. Essentially what we're doing here is we're multiplying by 100. When I do that, I get 585n minus 900. We put in zeros as placeholders, equal to 270. Two-step equation, I'm going to add 900 to both sides. Hopefully we don't need a calculator here. 585n is equal to 1,170. Divide both sides by 585. If you had to take a guess, what number do you think it would be? Turns out to be 2. Answer is n equals 2.
Okay, so we really kind of stepped up our game here. This is Algebra 1, only we're going a little bit deeper. Are we going to do this all year, Miss Dasher?
Absolutely. You need to be comfortable with doing this. If not, you're going to pay the price later on when we get to more challenging problems.
So if you didn't understand it, just rewind, go back, look at the details again. But now's the time you want to get these basics down because it's just going to step up from there and we're always going to use these basics, right?
Absolutely.
So on every video, we do a wrap up. It's very important to understand the significance of negative numbers and the parentheses when evaluating expressions. If you're not sure what we mean, go back to when we were evaluating expressions, take a look at that particular segment, and remember that -3 situation squared. That's what we're talking about. The negative is important depending on if it's inside or outside the parentheses.
You also want to make sure you're getting comfortable clearing fractions and decimals. It's going to make your life easier. You don't like them, so get rid of them. If you don't learn how to master it now, you're going to pay the price in the long run though, so come in the next time we meet with any questions you might have.
We hope that you enjoyed our first experience with video lessons, and if you have any questions,
Feel free to either message us or we'll talk to you the next time we meet.
bye.